All right, so in this transmutation problem, we have two big unknowns here, and we're trying to figure out what's going on. So if I want to know what type of radioactive process this is, I see that there are two reactants. Okay, that leads me to the idea that either this is bombardment or it is electron capture. Okay. I don't know yet what this item is here, so I cannot tell whether it's bombardment or electron capture, so I'm going to come back to that. Now, I'm trying to figure out what can I figure out first. Well, I see down here that the atomic number of this mystery item is 91. Well, if it has an atomic number, I'm going to look on the periodic table, and I see that atomic number 91 is, the symbol is Pa, protactinium. Protactinium, okay? So I've already solved one mystery here. Now, for the next mystery, I need to do the idea of conservation of mass number, conservation of atomic number. So I don't have enough information. I have two unknowns on the mass number right now. So I'm going to leave that for the time being. I'm going to look at atomic conservation of atomic number. So 92 plus x for this special particle, and it's on the reactant side, equals 91. So I said, well, what does x equal in that case? X equals -1. Okay. So I'm going to put a -1 in the spot for atomic number. Now I ask myself, what has an atomic number of -1? That doesn't even make sense. There's no element on the periodic table with a negative atomic number. But when I think about my special particles, I say, oh, when there's a -1, that is an electron. And I know that an electron has no mass, so there's a 0 for the mass number. And so now if I say, well, let me do conservation of mass number, 238 plus 0 equals x. Well, x is equal to 238. 238. Okay. So uranium is interacting with, has something going on with an electron, and what's produced is protactinium, which has the same mass number, but has one less, the atomic number is one smaller, which means it has one less proton. So there's a couple things I want to talk about here. One, we'd said that this is either a bombardment or electron capture. It turns out because there's an electron on the reactant side, this is electron capture. What's happening here is the nucleus of uranium-238 is pulling in an electron from one of its orbitals. So it's cannibalizing one of its own electrons. Okay. It's combining that electron with one of its protons and some other stuff, so to speak. And when it takes away that proton and that electron from its atom, it transforms it into a neutron. So protactinium has one less proton but one more neutron. And that's why the mass number didn't change, because protons and neutrons have the same mass. So I'm going to write added a neutron, lost a proton, but the mass did not change. Electron capture.